Welcome to the Environmental Health and Safety Virtual Classroom. I'm your instructor, Derrick A. I'm an environmental consultant and industrial hygienist, and I've spent over 27 years dealing with the recognition, evaluation, prevention, and control of hazards in the built environment. And we're going to talk about water incursion. Why prepare for water incursion into your building? Because water leaks happen. There are so many water opportunities in buildings, never mind rainwater and surface water runoff, which are potential issues. Think about how many plumbing fixtures you have in your building. We have water softeners, water heaters, we have drinking fountains, we have hot water supply, cold water supply, multiple sinks in our bathrooms, multiple showers. All of these things are potential water incursion sources. From your fire sprinkler line all the way down to your roof. There are many things in your buildings that can leak, and you need to be prepared for leaks to occur. It's not a matter of if, it's a matter of when. And your appropriate response will help reduce the damages that your building incurs, it will help reduce business interruption, and it will help protect your occupants from environmental hazards. So if you're a CMS regulated facility or a healthcare facility, you probably have or are required to have an emergency operations plan. And one of the hazards identified in your plan would certainly be water incursion. How to deal with it when it occurs, how to prevent it, ideally. As an industrial hygienist, having worked in thousands of facilities, this is the most common hazard that buildings face. Water incursion is going to be a problem for you today, and it's going to be a problem in the foreseeable future. Before we get into too many specifics, let's talk about the categories of water. Industrial hygienists, restoration professionals, the industry that revolves around prevention and response to water events, categorize water into three categories. Category 1 water, water that you can drink. Water from the domestic supply system, rainwater from the sky. It should pose no chemical and no biological hazard. If you have a water incursion with Category 1 water, clean water, you have the option to dry, and you have the option to remove building materials. From the other end of the spectrum, you have Category 3 water. Category 3 water is water that is presumed to be grossly contaminated, to contain chemicals or biologicals of concern. The quintessential example of this is going to be sewage. If a sewer line ruptures and into your building pours sewage, you're going to consider that to have bloodborne pathogens, E. coli, liver flukes, pinworms, etc. In between Category 1 and Category 3 is Category 2, and that's sort of a case-by-case basis. It could have some degree of chemical or biological contamination, but is not thought to pose a direct threat. With Category 1 water, you have the option to dry building materials in place. With Category 2 water, you're on the fence. Depending upon the material, you may replace or clean. With Category 3 water, you're going to remove materials, particularly porous materials that are affected by Category 3 water, such as carpet, drywall, insulation, etc. Here are some examples. Behind your toilet is a water supply line, and that often breaks. And if that line breaks, it's clean water coming from the city pouring into the floor. Category 2 water examples might include something like your fire suppression line or your fire sprinkler line if it ruptures. It's water that's been stagnant in that line, but shouldn't pose any chemical or biological hazards generally. Category 3 water examples might be water that comes in from surface water runoff. For example, if a river breaks its banks and floods your building, the water going from the river to your building could cross roads and fields and all number of things that could bring in feces, pesticides, herbicides, etc. Water can degrade in its category. Category 1 water can become Category 3 water given time or depending upon what it comes into contact with. So an example might be if you are a snowbird and you leave your house and you have a refrigerator line that leaks, but you're gone for 3 months. By the time you return, there will be significant bacterial and mold growth in your building that is no longer going to be considered Category 1 water that is standing on the floor, but it will be degraded to Category 3. Let's say you have a flood in a commercial building and you have chemicals stored in that building. Even if the water originates as Category 1 safe water, If it comes into contact with pesticides or oxidizers or other chemicals of concern, that water will degrade quickly or immediately to Category 3. So keep in mind that the origination of the water is important to understand. If you have a flood in your building, you want to quickly identify what is leaking, but also how long has it been leaking and what could it have come in contact with that might make this water more of a concern. If you have a Category 3 event, like a sewage leak, keep in mind that sewage doesn't always look discolored. The category of water has nothing to do with the color. Water can appear very clean and be quite hazardous, and water can appear quite turbulent and be relatively safe. It's not about the color of the water. It's about the origin and what it came into contact with and how long that water has been sitting. If you have a Category 3 event, you don't test. We don't test for hepatitis. We don't test for pinworms. We don't test for pesticides. It's presumed to contain those hazards, and you want to have a hazard appropriate response. Your emergency operations plan should have a pathway for you to address those things. Generally speaking, you are going to have contracted a restoration company, a professional firm that has the personal protective equipment, the insurance, the licensing, the training to deal with hazardous situations. Disinfection alone is not enough. Although disinfectants will be used when you're dealing with a Category 3 event, the disinfectants are really more to protect the worker who is picking up the sewage-laden carpet. They're trying to reduce the pathogens associated with that carpet because some poor individual has to actually cut that carpet up by hand. Although they're wearing respirators and gloves, they are dealing with generally human feces, for example. So they will be applying a disinfectant to reduce the health risk to themselves. But disinfection alone is not enough. Those building materials are going to be removed, that area is going to be cleaned, and then a disinfectant is going to be applied so that other people, unprotected people, can return to your built environment. The key to effectively addressing water or following your emergency operations plan is a rapid response. Faster, in this case, is better. And the way to facilitate faster is to have vendors pre-vetted, their information readily available to anyone on staff, and you want to have backups to your backups. You want to have a restoration company on speed dial and a second restoration company on speed dial. You want to have an industrial hygienist on speed dial and a secondary industrial hygienist on speed dial. Same thing goes for your plumber. You want to have a plumber on speed dial so that when this event occurs, you can call those people and they can immediately come to your facility. They have a familiarity of your facility. They understand your processes, what's critical or most critical to you, and they can respond in time. A rapid response is integral to having a successful water mitigation. Why is that so important to be quick? Well, number one is the longer you wait to stop the water and the longer you wait to respond to the water, the footprint of your loss will grow laterally as water migrates from place to place. If you're in a multi-story building, also water will migrate from floor to floor to floor. So a rapid response, stopping the water immediately, that means knowing where the water shutoffs are, and then getting a restoration company or getting people from your team on site to dike, which is to block water from moving laterally, and to extract or vacuum as much liquid water as possible. These are keys to setting up a successful drying event. For example, it's about 1,200 times more efficient to vacuum water than it is to try to dry water with a fan or evaporate water. So the more water you can get as a liquid, the better. And the faster you respond, the less footprint you have to deal with. Also, if you respond quickly, building materials won't be wet as long. The longer materials are wet, the more likely they are to become damaged, swollen, stained, rusted, discolored, etc. Speed makes a difference when it comes to the degradation of water. Remember that water that is Category 1 or clean water can turn into Category 2 or 3 with time. For example, if you don't respond quickly, you will end up with the growth of mold, which we've talked about in other sessions. And don't overlook the obvious health risks that a flooded building presents. Slip and fall, electrocution, or chemical exposure. If you have a multi-story parking structure underground and it's flooded, you can expect that those vehicles are going to be emitting oil and gas, and sending an individual into that environment is a hazard. For all of these reasons, rapid intervention is critical to having a successful outcome with your water restoration. So we've talked about the basics. Now let's get into a little more detail on addressing a water event in your building. Moisture mapping. We need to find the water. Just because something appears dry does not mean that it is dry. There are tools that you should have in your arsenal, such as moisture meters or infrared cameras, that will help you determine when building materials are wet when they may not obviously be wet. Sometimes things are in standing water. They are wet. Sometimes things are water stained. They appear wet. But there are many things that can be wet that will support the growth of mold or will damage your building materials that are not obvious to the human eye or to the touch. So your professionals or maybe your in-house team should have the right tools to assess what is the footprint of this water event. Infrared cameras measure temperature difference at the surface. On television, they will lead you to believe that these devices can see through walls. They do not. They measure the temperature difference at surface, but that can be used to your advantage because things that are wet generally are cooler, or in some cases, warmer than the surrounding building materials, allowing you to quickly identify what might be wet. You would follow that up with a moisture meter. There's a variety of moisture meters available. Some penetrate the wall where you stick them in and it runs an electrical current between the pins. Some use electromagnetic frequencies. They're all a little bit different, but the important thing is moisture meters help you confirm what is wet and what is not. Having worked on thousands of projects, if you're a facility manager, it makes good sense to have a moisture meter. Infrared cameras are a little more expensive. Moisture meters are less than $1,000. They last many years, simple to use, robust devices that can help you identify what's wet and what's not. So if you're doing this in-house, you should have these tools. If you're contracting with a restoration professional, they should have these tools. Once you've established the footprint of your loss, both horizontally and vertically, then you can begin to attack it. What is step one in the attack? Extraction. You want to suck up the water that is in liquid form as much as is possible. There are many fancy extractors, but some are as simple as a wet-dry vac. Others are truck-mounted or even rideable extractors. But the goal is suck that water up in a liquid form and get that out of the building. Step two is you're going to remove wet building materials that are non-salvageable. There's two ways to dry a structure. One is to come in and remove everything that is wet, and the building by definition would be dry. The other is to remove nothing, but to extract the water and to dry the building materials in place. Normally those are extremes. Most projects are somewhere in the middle. So there will be some building materials in general that you will probably remove because they just can't survive the water or they are in the way of drying other materials. Vinyl base cove is a good example. Vinyl base cove is great when you're mopping the floor because it keeps your mop water from getting into the drywall. But it works the opposite way. If water is already in your drywall, that vinyl base cove will not allow water to evaporate out into the atmosphere, increasing the potential for mold, increasing the potential for rust, etc. So some building materials will be removed to either access, or some building materials will be removed because they are unsalvageable from the get-go. Once you've mapped your moisture, once you've extracted your water, and once you've removed the building materials that are unsalvageable or that are in the way of other materials, a drying system needs to be put in place. What is a drying system? It's a combination of tools and techniques to ensure that building materials that are wet and are going to remain in place become dry. Typical drying systems are going to include air movers, some sort of fan that moves air to facilitate the evaporation of water from surfaces and to depressurize or change the pressure at surfaces to prevent the growth of mold and bacteria. Drying systems will often include dehumidifiers. Dehumidifiers take water that is in airborne form or a vapor form, liquefy it, and remove it from the building. There are refrigerant dehumidifiers, there are desiccant dehumidifiers, which are all beyond the scope of this education. But just understand that there are a multitude of tools for drying a single room or a multi-story office building that can be deployed. A drying system will be very unique to your loss, very unique to your building. If you have in-house capabilities to address water leaks, remember that there can be hazards you may overlook. One is wet building materials and extension cords, for example, don't mix. You don't want to have electrical devices in standing water. There's a risk of electrocution. Depending upon the loss, if the loss is category 3, you don't want to go from hero to 0. It's very common for people to say, oh, we have a category 3 loss and we want to remove this wet material from an area that's contaminated with water to a dry area or an unaffected area. Well, if it's category 3 water, you're basically taking a sewage-laden box of papers or a sewage-laden couch and you're putting it in a room that otherwise would not need to be addressed, but now is part of the loss because you've moved sewage from point A to point B. You've tracked in and out of that facility, possibly contaminating yourself, your vehicle, your tools. So keep in mind that there are hazards that you need to be aware of if you're going to be doing this work in-house. If your built environment includes a commercial kitchen, you're probably already aware of aseptic techniques and prevention of cross-contamination. Those same principles apply to a water loss, particularly if it's category 3. You don't want to move contaminants from place to place and otherwise put people at risk when there's no need for that. Water restoration is not a federally regulated activity. Restoration companies can come to your facility and they can do this work, dry your building, but in the process go from, again, hero to 0 by disturbing federally regulated materials such as asbestos. Make sure that you or your restoration company consider asbestos before you start removing building materials, because you don't want to be responding to a non-federally regulated event only to disturb federally regulated materials. As an example, the #1 citation we see associated with flood events is the inadvertent disturbance of asbestos. The restoration company comes in, attempting to be helpful, and very quickly starts cutting out building materials to speed your drying process, but does not check to make sure the regulated material, like asbestos, has been tested. And a regulator will come to the site and they cite everyone that has command and control of the building. Obviously, they would cite the restoration company, but they would also cite building management. They would cite the building owner. Everyone has joint and several liability when it comes to asbestos. They can go after the restoration company 100% or a fraction. They can go after the management 100% or a fraction. They can go after the building owner 100% or a fraction. Same with the general contractor. Anyone who has command and control of the building will be liable for an asbestos disturbance. The best way to avoid an asbestos disturbance is to test your building materials before you have a flood event. You don't necessarily have to test every building material in your facility, but the building materials that you're commonly contacting or that would be commonly affected by a flood, like drywall systems and ceiling tiles, perhaps even flooring systems. If you test those in advance, you know whether they contain asbestos or not. You have those records. So when the restoration company arrives, you just hand them the records. Here's what contains asbestos, here's what does not, and they will know what they can and cannot disturb. The other option is to wait until you have a flood event. But again, these flood events always occur at very inconvenient times when laboratories are often closed. But you can have asbestos testing done on demand. When you have a flood event, someone can come to the facility, collect those asbestos samples, get those to the lab, and get the sample results turned in a rush. Of course, there's some inconvenience factors and there's some expenses for rush asbestos sampling. Floods happen, and you need to leave as little to chance as possible. So make sure that your emergency operations plan is well thought out so that you can reduce your business interruption, so you can reduce the hazards to your building occupants, and so that you can protect all your stakeholders.